Can you guys hear me? Okay. Hello, everybody. I want to thank BCI for the invitation. So today I'm going to share my view of IoT security and privacy. My name is Xinwen Fu. I'm a professor at Department of Computer Science, University of Massachusetts Law. So here is an outline of today's talk. First, I'm going to introduce what is the Internet of Things and what is actually cyber physical systems, because cyber physical systems are often mentioned together with IoT. So here you can see it's the definition of IoT. So IoT is defined as a worldwide network of interconnected objects. So those objects can be uniquely addressable. Means, for example, each object has an IP that we can actually reach the object. So the key point here is the interconnected objects. So you can see here, the objects can be anything. It can be like a humidity and a temperature sensor. It can be the industry machines. It can be the damper, right? And it can be many other things. So those things will actually create the data, and the data will be uploaded into the cloud for further processing. And then everything will become smarter, right? So let me give you one example of the IoT. So this low-cost air quality sensor network. So here is the example here. You can see back here, so we have this IoT device. So this is basically an air quality monitoring device. So within this tube here, actually it contains a microcontroller. A microcontroller is a small computer, and it also contains actually the PM sensors, so air quality monitoring sensors. So the microcontroller is going to read the readings from these PM sensors, right? It will send the data to the server on the internet through the local Wi-Fi router. And once the data goes to the server, then so this kind of server can actually put the data on a map, and everybody can use their smartphone and other kind of computers to look at the data and find out where it's polluted, right? So this is a typical, I think it's very typical IoT example. And so now the problem is, what is the thing here, right? Because we mentioned it looks like a thing is everything. And so here, if we look at this example, it seems a thing is a device with the internet functionality, and it also has the sensing functionality. We put both the cyber function, and also we put the sensor function together into one device. So this is one thing which has both cyber and the sensing actuating functionalities. So we call this as a thing. So this look at is a thing in everybody's mind. Then there's another thing called a cyber physical system here. So people mention cyber physical system a lot. And let me show you one example, the smart building example here. So in this example, I have actually a video here. So you can see here we have a damper. So when you actually move the handle, then the damper will close. But actually, we can also use this kind of a controller here to control this damper. So you can see there's a handle here, right? And this will be attached to here. And then we can actually send a command to this controller. The controller is like this one. So the command can be sent to the controller. Then the controller can actually rotate the handle and to open or close the damper. And so this is a typical smart building application. People often call this as a cyber physical system. So what is the difference between this example and the last example? You can see here in this example, the thing, the actual thing here, the damper here, is separate from its controller, right? The other parts are very similar. We can have internet, and we can have firewall. For example, in last example, we have the Wi-Fi router. The Wi-Fi router has also Wi-Fi. Now we may have a local area network. The local network, for example, in last example, is your home Wi-Fi network. But in the case of this kind of a cyber physical system, people actually often use a specialized communication protocol for the local area network. For example, for smart building, there are other kind of communication protocols called BACnet and KNX. Those are special kind of networking protocols. So you can see here, right? So this is we can see the difference between CPS and IoT. But really, if we compare these two, you can see from the perspective of architecture, IoT and CPS are similar. So let me show you the architecture here. Again, let's look at it from left to right. So left, you can see here, we have the cyber, we have the internet, then we have the workstation, which can be used to remotely control anything, right? And then we have internet, then normally before anything goes into our local area network, then we have the firewall, try to block known attacks. Then here, I think it's a major difference between CPS and IoT. And if we really differentiate them. So we have local network, right? And this local network in terms of IoT, then this will be Wi-Fi. But people, when we talk about CPS, people are talking about those backnet, those specialized networking protocol. Here now, so the network will be used to actually remotely send commands or communication with this controller here. So you can see here, this controller is very special. I think this controller actually differentiate IoT and CPS in people's mind. So the controller here, you can see because it needs to communicate with the cyber. So for sure, it will have network cards and a special kind of cyber I/O devices or capabilities. But at the other end, then because the controller will be used to control the actual things, so it will have the actual special individual thing I/O, right? And maybe just a wire, maybe it's a lot of kind of different kind of I/Os, many wires, maybe single wire, many wires, and really depend on the application. So you can see here, in the case of the damper, right, you need actually the actuator and other kind of thick wires to really control this damper. But for this kind of a small sensor, right, for example, this air quality sensor, then you just need one wire to actually really read the data from here, maybe send a command to this one. So you can see really from the perspective of architecture, and the architecture is very similar for both IoT and CPS. So really, I think we don't need to differentiate IoT and CPS if you really don't want to do that. And of course, the applications can be different. So when we talk about the CPS, people often think about those big things. For example, the cars and smart buildings and many other kind of industry machines. You can see in those cases, the machines, right, the actual machines, and also their controllers are separate, right? So that's when people think about the CPS. Then when people talk about IoT, people think, oh yes, this is one thing. So the IoT, this is thing actually, and all the controller, they are put into one device, so they look as one thing. I think that's when people are thinking about IoT. So this is my view about the IoT and the CPS. But from now on, I'm just going to call them IoT, right, for simplicity. So IoT has a bigger problem. It's a security, because IoT will be deployed everywhere. So if we don't care about security, then our privacy, our security will be compromised. When we talk about IoT security analysis, we have to look at from different aspects. So here, at least 1, 2, 3, 4, 5 aspects here. So basically, you can see here, we have to look at the security privacy from hardware. I'll give you one example. Most of the devices, they have the communication port. But what if somebody can attach their own cable to the communication port, and they can really read your data out of the device? So basically, when you actually deliver your IoT device, you may want to think about, do you want to disable those kind of programming ports, debugging ports, or communication ports? Then we also need to talk about the networking. And so because your device will be in a field, maybe somewhere, and you really need to make sure and only authorized people can use it, right? So that's when we need authentication. And every device will have code. And some of the code runs on a well-established operating system, for example, Linux. Some of the device just is a piece of code, and the code directly works on the actual hardware. So means, so if there's OS, you have to think about if the OS is secure, and don't use any OS from the internet without any kind of idea what it is, right? And also, why software security engineering is so kind of popular, because now everybody has to write the software for each individual device, and so you can get a big chunk of money. But the problem is most people are not educated with the security knowledge. And when they write the software, there are a lot of actually software problems. For example, buffer overflow is a popular attack, right? And then finally, we have to think about data, because the device will create a lot of data. And do you actually encrypt your data? Do we use a blockchain? Shall we use blockchain actually, for example, to secure the data, and to actually make a good kind of a database, a ledger to document the data? So we have to think about all those things. Let me tell you a few examples so that you know if we really don't care about the security, if we expect different aspects of the security of IoT, what will happen? So you can see here, this is a smart plug. And a smart plug basically is a device that you can actually put, for example, your lamp cable, power cable. You can hook your power cable to this socket here. Then you can remotely use your phone here to actually turn on and turn off this socket. I have a few at my home. And so you can actually control this device, for example, this smart plug locally. You can also control them from remote. And for this case, I'm talking about the EdiMax smart plugs from that company called the EdiMax. So they've set up a few servers on the internet. So they have the authentication server and document a lot of names and credentials. They also have the command release server, means when you send your command from your cellular network, right, to this device here, and the command will first go to actually the command release server, and the release server will relay the command into your smart plug. Okay, so you can see this is a typical use of IoT, right? Now, what is the problem here? So this system has a lot of problems. First, there's no encryption. Because they have no encryption, we can actually dump all the traffic and analyze what is going on, what is their protocol. So we find a lot of problems. So the first attack we find out is a device scanning attack. So we find out their authentication is really weak for each device, right? When you try to control the device, you have to send the username and the password. But the username of each device is the device's MAC address. The problem is MAC address is predictable. So for example, when EdiMax produces their devices, EdiMax will use the MAC address allocated to them for those devices. If you search online for EdiMax, you will find the chunk of MAC addresses allocated to EdiMax. So then the problem here is, okay, now we know what addresses can be the username, right? And we also know the default password is 1234. Now we can do this kind of device scanning attack. It means we try each MAC address, we try the default password, and then see if actually we can get some response from the actual device. So we did a lot of experiments. So here is a table to show you when we send the username, which is the MAC address, when we send different password, what is the response from the EdiMax communication system? So you can see here, if the plug is online, if the password is correct, then we got 1070. Then we know, yes, the plug is online. We have this device, they have this device, and the password is correct. So you can see here, so based on the different response codes, then we know if EdiMax, this kind of plug, is online or is offline, and so also does it use the default password, and does it actually use another password? Actually, we did some experiments. We found out 50% of people still use the default password. So you can see what is the problem. And if they don't use default password, we can deploy a brute force attack. Means we try different password with this MAC address and see which one will succeed, right? But the problem is sometimes people use a long password with a lot of complexities. In those cases, it's very hard to enumerate all possible passwords. but we have another attack called the device spoofing attack. The reason is basically this authentication server has issues. And what we did is actually we designed a fake plug. We wrote our software, and this software will behave as a fake plug. And this fake plug will have the same MAC address as a victim plug. And so we just don't know the password. But this system has a vulnerability here. And so when we actually register our fake plug with this authentication server, and this victim plug will be removed from the database. So now what happens is when user tries to use this smartphone to control their own device, so they will send the username, they will send the password, but the username and the password will actually go to our fake plug. In that way, we got the password of the victim plug. Then we take off this device with this fake plug offline. Then after we take off this fake plug offline, this smart plug will actually register itself again with this server and will become online. But at this point, we know this is this one's password. We can control them, right? Actually, we can control all of them. So you can see the problem. We told Edimax you have problems. We fix some of the problems. This is called responsible disclosure. So this is the attack against the Edimax smart plug. So here I show you another example of attack against the air quality device we just mentioned. So these are internals of this air quality device. And you can see here, this is actually the microcontroller, small computer, right? Today, the small computer is only like a $2 or $1. So, but this small computer actually is bigger than Intel's early CPU, okay? And so then this is the actually programmer and the power board. This is the actual air quality sensor, and this is the micro USB cable. But really, what happens, they don't have any hardware security. We can just hook a normal smartphone micro USB cable to this micro USB cable port here. Then we can actually read anything on the flash, including users' password, Wi-Fi credentials, anything you store within the flash of this device. So, and also we can actually also flash our own software firmware onto this device. So it means if you buy their device, I go to your home, I just hook a cable to the micro USB port because you put it outside, right? Then I can just change anything. And so that's the problem. And also there's a problem here. And so what happens is, we can actually try to pollute the air quality data. So they don't have any authentication over there. So we can, because they also use MAC address as the identity of the device. And then we can just pretend to be the actual device and send out arbitrary data. So here I show you, so before the attack, right, you can see everything's normal, even the pollution level is 0, means really there's nothing in the air, everything's good. But after we send the fake data, and we can actually increase the pollution level to anything we want. And because they use average, when we send our own data, right, and when they do the average, so our fake data will affect the average. So we can change anything of the rating here, okay? And to show you an attack about a smart building to a CPS, right? Because now we basically treat IoT and CPS the same. And so this is an example in our lab here. You can see basically this is a typical Siemens smart building panel. So this is a smart building. You can see controller. And then this one is the actuator. We don't have the damper connected to this actuator, but you can collect a damper to here so that you can use this controller to control the damper. Here we have the Raspberry Pi. So the Raspberry Pi can actually send commands to the damper and to the controller here and turn the damper, okay? And turn the actuator so that we will change the damper. So this is a typical the Siemens smart building network. What is the problem here? The problem is there's no security in most smart building systems. if you could get into the local area network of a smarter building, you can control any of that. And so here, I show you one video here. So in this case, we are demonstrating this panel has no security. We are on campus network. We are on campus Wi-Fi network. We can actually send the commands from the campus network to that panel to turn the actuator. So you will see the actuator will turn. It will turn here. So now you see it actually speeds now. And so this is the problem here. And basically, most of the smart building system have the same issue. If you can get into the local area network, you can just change them arbitrarily. You can turn off even the power of everything. Now let me talk about the defense. So the good news, actually, we can really secure our IoT systems. And again, when we try to secure our IoT systems, we have to secure them from end to end. And we have to secure them hardware. For example, we should disable the debugging ports when we deliver our final products. And we should have authentication for networking. We should have secure OS. We should have software without bugs. That's impossible. That's why we have jobs. And we also need to encrypt our data and also maybe use blockchain to make sure nobody will cheat your data. Everybody's accountable, right? And so I show you two examples of our projects here. So one thing is here I show you, this is the one device we are producing. And you can see this one is just for classroom use. And we have a humidity temperature sensor here. And so here then we have our ESP32 microcontroller. And the thing I want to emphasize is this crypto coprocessor. People were talking about security components are very expensive, but really no. And for most of the security, we really can use cheap devices to implement the security. For example, this is something called a crypto coprocessor. It's only 50 cents, but this 50 cents will be very valuable. Why? Because now this one can actually do encryption, decryption. It can also store your keys so that nobody can steal your key. For example, we mentioned when people dump the firmware, right? They will get your keys, get your password. But if you store the keys here, they cannot do it. Okay. So the other one is called it's a lot of device we are making here. It's the air kind of environmental sensor. And you can see here, in this case, we are using a special microcontroller from Microchip. This special microcontroller has a special kind of a CPU called a TrustZone. It has TrustZone. So basically, we put the unsecured and trusted application into something called a non-secure world. So it's a non-secure OS. Then we can use another OS on the trust zone called a secure OS to monitor what is happening within the unsecured OS. For example, we can actually put the air quality monitoring applications and reading all the data into the unsecured operating system. And then we can use our secured OS to monitor if there's any kind of hack activities within the application. In this way, then we can actually tell people, yeah, there's something phishing happening over there. And so now let me summarize what we are talking about here. So in this talk, I just try to tell you, really, IoT and CPS are very similar in terms of architecture. Maybe we really try to different IoT and CPS from the applications, but from the architecture, they are very similar. Maybe the I/O is different, local area network is different, but the architecture is very similar. And also, when we try to secure IoT, we should secure them from end to end. And also, we have the resources, we have the hardware, and everything to do that. The only thing is, because there are so many buildings, you cannot replace all of them with new devices. I mean, the replacement cost may be the largest obstacle to secure our devices. The money is a big problem, right? And so here, really, I want to emphasize the recent advance in hardware and other things allows secure IoT and CPS. And so, yeah, so this is basically what I try to talk about. And any question and answers, any questions?